Good morning, students. Today, I am Radhakrishnan, Assistant Professor Computer Science and Engineering, Community College of Engineering and Technology, ToC. Today, we discuss about undecidability, undecidable problems in theory of computations. Undecidable problem, that is a recursively enumerable language. Undecidable, generally we concentrate on undecidability. Now we concentrate on undecidable problem, that is recursively enumerable languages having the undecidability we are discussing. Introduction. A language L is recursively enumerable. A language L is recursively enumerable if there exists a Turing machine M such that L is equal to L of M. If a language L is recursively enumerable language means compulsory the language is presented in one Turing machine, which is accepted in one Turing machine. We call as recursively enumerable language. So that the language L is recursively enumerable if there exists a Turing machine M such that the language L is equal to L of M. A language is recursive language when there exists a Turing machine M such that L is L of M and M halt on every input of W. So recursive language means compulsory the language which is present in the Turing machine M, and also whatever the input is given it will be accepted and Turing machine move to halt state. But in terms of recursively enumerable language, there is a Turing machine M such that the language which is present in Turing machine alone, whether the Turing machine will goes to either by accepted state or halt state, there is no issue for recursive enumerable language. But recursive language, it should be accepted in the language, and as well as whatever the input is given, the machine goes to halt state. This is a regular grammar. After that, we are discussing about regular grammar. After that, context-free languages. After that, recursively enumerable languages. Decidable problem. When we say that the problem is decidable, decidable means the problem P is decidable if it can be solved by Turing machine T that always halt. So the problem which is solved by Turing machine T and the Turing machine is moved to halt state. That particular case we call as decidable problem. We say that P has an effective algorithm. So B effective algorithm means which has the solution. That's why we call it as effective algorithm. Note that the corresponding language of the decidable problem is recursive. So a recursive problem or decidable problem means both are all same. Recursive problem, what is the definition? Already in previous slide we discussed about recursive language. The recursive language L, which is nothing but it's accepted in the Turing machine M, and M halt on every input W. So M move to halt state. The same way in the decidable problem, the problem P is decidable if there is, it can be solved by Turing machine T and always halt. Compulsory, the Turing machine goes to halt state. That language is called as recursive language. A problem is decidable if some Turing machine decides solve the problem. Yes. Decidable problems. What is the decidable problems? Does the machine M have 3 states? A problem is decidable if some Turing machine decides the problem. Question. Decidable problem means what we discuss. Does the machine M have 3 states? If the string is in the form of binary format and the DFAM accept any input. These are the points we need to keep in mind for decidable problem. Having the 3 states, binary numbers, and accept the input string. Undecidable problem. Undecidable problem means a problem is undecidable if it cannot be solved by Turing machine that halt on all the inputs. The problem will not be get the solution and the machine goes to halt state. Halt state is entirely different from accept and reject in the Turing machine. The halt means either the input will be accepted or not. The Turing machine will be present, stop their process means that is also halt. So in generally, decidable problem means it should take the input and accept the particular input and move to halt statements, accept halt. Suppose the problem is goes to halt state without accepting their input, we call as undecidable problem. Note that the corresponding language of the undecidable problem is non-recursive problem because the language will not be accepted in the Turing machine. That's why we call as non-recursive. The Turing machine that decides the problem answer is yes or no for each instance of problem. Yes, definitely we define input problem instance. The input will be given to the Turing machine M. It will be accepted the input and goes to halt statements yes. If the Turing machine will not be accepted the given input and move to halt statements no. If the answer is yes, then halt is yes state. If the answer is no, then halt is no state. So this yes or no is defines that where the input will be accepted is move to halt statements go accept halt, that means be yes. The input will not be present in the Turing machine, so it will not be taken as a input and produced as reject and halt means we go with state will be no. So we call as the answer is no, then halt is no state. Properties of recursive and recursive enumerable languages. The complement of recursive language is also recursive. Second one, the union of two recursive languages is also recursive. Third one, the union of two recursively enumerable languages also recursively enumerable languages. If a language L and complement L dash are both recursively enumerable, then L is recursive. If a language L and complement L dash are both recursively enumerable language means, then L is also recursive language. Properties will be new. Some important consequence, let L and L dash be a pair of complementary language, then either. That is also one of the property. Both L and L dash are recursive. Either L or L dash is recursively enumerable language, or one of L and L dash is recursively enumerable but not recursive. The other is not recursively enumerable language. A simple undecidable problem. A membership problem we call as an example of undecidable problem. Membership problem. Input is Turing machine M. The membership problem we consider decide that the undecidable problem. So input is Turing machine M. String W is the input. Question: does M accept W? That is our question. Does the Turing machine M which accept the input string W? W is belongs to L of M or not. That should be verified. Theorem: the membership problem is undecidable. That is, there is a machine M and input W for which we cannot decide whether W is belongs to L of M or not. That is the concept of theorem. So assume that the contradiction that with the membership problem is decidable. So we show that and the problem is undecidable. So we can consider as contradiction. Assume that the given membership problem is decidable. In this decidable means it will be accept the input and goes to halt state meaning. There exists a Turing machine H that solves the membership problem because the given problem is decidable. Decidable means recursive. Recursive means accept the problem and solve the problem. So that we consider the existing Turing machine H that solves the membership problem. M is the Turing machine. W is the input. Is similar to the halt Turing machine H. It will be accept yes or no. M, if in case of yes means M accepts W. In terms of W is not accepted means M rejects the word W. Let L be recursive language. So L be a recursively enumerable language. Let M be the Turing machine that accepts L. We will prove that L is also recursive. So we will prove that L is also recursive. So we will describe the Turing machine that accepts the L and halt on any input. Then recursive means it will be accept all the inputs and produce the as a halt state. So Turing machine M accepts W. The Turing machine M, we will produce the input W, which is accept yes or no. Yes means accept the W input string. If it is no, reject the input string. Therefore, L is recursive. Since L is chosen arbitrary, every recursive enumerable language is also recursive. So every recursively enumerable language is also recursive. That is also one of the property. But there are recursive enumerable language which are not recursive. That is also another proved concept is that. So every recursive problem is not recursive enumerable language, but there are some recursive enumerable language which are not recursive also possible. Because our contradiction part, so therefore the membership problem is undecidable. So it will be contradict about our initial assumption because decidable. Here concept will be the undecidable value. So automatically our initial assumptions will be entirely different from our obtained result, so that the problem is undecidable problem. Next, we discuss with the post correspondence problem. Undecidability about strings is the concept of post correspondence problem. So till now we discussed about undecidability about Turing machines. Now this particular concept we concentrate on undecidability about strings. So we need a tool to prove that the previous problem, the contextual language is undecidable, that we call as post correspondence problem. What is a post correspondence problem means? We can consider two set of states with the help of n strings. For example, we consider two sets A and B. Both the states will be A and B equal to W1, W2 up to Wn, and B equal to V1, V2, V3 up to Vn. So both the sets A and B sets having n number of elements. Next, there is a post correspondence solution. Is that if there is a sequence of I, J, K up to I, J up to K such that PCP solution is Wi, Wj up to Wk means is equal to Vi, Vj up to Vk. So indeed sir, maybe a repeater or omitter. So whatever the input characters will be, maybe the repeater values will be presented or some other reorder also will be required. So PCP solution is Wi, Wj up to Wk is equal to Vi, Vj up to Vk. For example, A rules having three alternatives, three elements, B having three elements. So W1 100, W2 11, W3 111, and B sets V1 001, V2 111, V3 11. So through two states, two set of input characters, n number of elements. So both A set having three values, B set having three values. So PCP solution we have to choose an appropriate rule. The identifying the solution is 213. How it will be identified means we have taken as a first element in A set means definitely we will start with first element with B sets. At the same time, the derived character strings also to be matched. For example, here W1 start with 100, V1 start with 001. So that particular case, we are not in position to choose first element as a starting. So that we start with the second element W2 from A state, V2 from B state. That case 11, 111. So first two elements will be matched. So what is the third element in the first set? That means derived string, no value. But in terms of B part, we have in the third element will be present. But what is the third element? 1. So that particular case, we have to choose the A set, start with 1. So we choose the first character, upper 2, 1. After that, 1, 0, here 0, 0, 1. So till now, up to the 2 points, what are the values will be generated from A states? W2, W1 means 1, 1, 0. In terms of B states, V2, V1, upper 1, 1, 0, 1. So automatically, 1, 1 will be exceeded in the B value. Next, we have to choose the third element. So A3, that means W3 means 333, so 111. V3 means 111. Automatically, it will match with the sequence and match the entire characters at the level of V3 selection, third selection. So finally, we get W2, W1, W3 is equal to V2, V1, V3. The sequence will be 111, 00, 111. The same sequence for also 111, 111, 00, 111 for both the cases. So the PCP has a solution of 213. The next one problem, this particular case, there is no specific param because total length of the string B is smaller than the total length of the string A. For example, A total character will be 2 plus 3 plus 4, 4 plus 3, 7 plus 2, 9 characters. B having 1 plus 2, 3 plus 3, 6 characters. So that is a not equivalent. In terms of first one, 3 plus 2, 5 plus 3, 8, and B having 3 plus 3 plus 2, 8. So both are equal. That's the solution is possible. But here the length will be mismatching. There is no possibility for string length equal. So there is no solution for this problem. The PCP problem, modified PCP problem means the same concept will be again repeated for another one different way. The W1, W2, W3 is a number of elements in state A, and set B equal to V1, V2, V3 up to Vn. BCP solution is 1, ijk. So by default, you start with first is the solution. Modified PCP, the same concept will be implemented, but in PCP problem, we are not in position to compulsory start with first character. We have to choose any of the value. But in modified PCP, we have to choose the element as very first element is the first solution step. So by default, we start with the solution is first element. That means W1 from A state, A set, V1 from B set. So automatically next we have to choose on any order Wi, Wj up to Wk equal to V1, Vj, Vi, Vj, Vk up to Vk. So finally we will get a solution as W1, Wi, Wj up to Wk is equal to V1, Vi, Vj up to Vk. That is our solution. So now we consider the solution as example A equal to 11, 111, 100. B equal to 111, 100. We start the solution as 132. This is our solution. The same PCP problem methodology we have to implement, but we are start with very first letter will be the initial level one. So that's all about the post correspondence problem and undecidability about strings. Thank you, students.